In this video, we're going to look at functions and we're going to look at sketching a parabola. So there are three things you must know about all the functions. Remember, we have linear, parabola, hyperbola, and then we also have the exponential. So the three things that you must know about each and every function is the characteristics, and you must also know how to sketch that function, as well as finding the equation. So whenever someone says parabola, say, oh no, I know the characteristics of a parabola, I know how to sketch a parabola, and I know how to find the equation of a parabola. If you know those three things about all the four functions, then you'll be okay. So let's look at the characteristics of a parabola. A parabola has three standard forms. Last year you only dealt with one. Now we're going to deal with three. The one that you dealt with was y equals to ax squared plus q. And what's going on over here? Well, we know that if the a value is positive, you're going to have a smiling parabola, right? And if the a value is negative, then you are going to have a sad parabola. So that is what's going on over there, right? So that's a parabola. Now, that's what the a value from the standard form tells us. But what does the q value tells us? Well, if we put this on a Cartesian plane, right? Let's say put that on a Cartesian plane and this on a Cartesian plane as well. You'll start to understand what the q value tells us. So the q value is going to tell us the y-intercept. Firstly, you must understand that the q value tells you the y-intercept and turning point. So the q value is going to tell you about the y-intercept as well as the turning. Okay, let me just spell that, write that a bit better, so that those kids who complain, oh, say I can't see. You can't see, but I said what's going on. Just kidding. Turning point, right? So that's what's going on. You must know that the q value is going to give you the value of the turning point as well as the value of the intercept. They are the same thing if you got this standard form. So over here, over there where the graph cuts the y-axis, that is known as the y-intercept. So it has the coordinate 0 and whatever the q value is. 0 and whatever the q value is. And also over there, you got the y-intercept where the x is 0 and the y value will be whatever the q value is. But you must also understand that it's not just a y-intercept, but also a turning point. Now, what is a turning point? Now, the turning point, let's write it down. Turning point is the point on the graph where the graph stops. So let's say stops decreasing and starts increasing, and vice versa, right? Vice versa. So what is the turning point? The turning point is that point on the graph where the graph is going to stop increasing and start to decrease. Now, how do you know increase and decrease? Let's look at this first graph here. You're always going to picture yourself standing from the left and you are walking to the right, but on the graph. So if you are walking on the graph like this, you'll be going down, hence you'll be decreasing. So over here, you'll be D for decreasing up till you get this value here, this called the TP for turning point. Then you will start to go uphill, whereby you'll now be increasing. So that's what's going on over here. A parabola is a graph that will decrease then increase, or it will firstly increase, and by the turning point it's going to then start to decrease. So a parabola is such a graph, and it has a point where it stops increasing and starts to decrease, and that value is known as the turning point. In this standard form that we have currently over here, the turning point has the same coordinates, or is the same point as the y-intercept over here. But the turning point also tells you something. The turning point also tells you about the equation of axis of symmetry. So let's write it down. Equation of the axis, equation of axis of symmetry. Okay, symmetry. All right. That has the equation y, equation x equals to, it's a vertical line. So you will have x equals to the x value of the TP, which is the turning point. So a parabola, you have to understand what's going on there with the turning point. The turning point is very, very important when it comes to a parabola. It also gives you the axis of symmetry. So we mean that if I were to draw a nice big parabola for you here, and I say this is the turning point, that means that if I take a knife and I cut it here, I cut the parabola on this line, which is then, let's say this coordinate is -1 and 2, then this line will be x equals to -1, because it must be equal to the x value of the turning point, right? That's what we just said over here with this little formula of ours. The equation of the axis of symmetry is that line that I can cut. This line, this dotted line, that's the axis of symmetry, and its equation is this. What does it mean? It means that if I cut the parabola in half over there, then this part will be exactly like this part, right? So there will be two halves that are exactly the same. So that's what the equation of symmetry is all about. And in this situation, you must understand that the equation of symmetry will be the x value of the turning point. So that's what's going on over here. If you have this standard form, that's all the information you will need. Right, let's go over to the next standard form over here, which is the y equals to a bracket x minus p raised to the power of 2 plus q. Now, when you have the standard form, again, the a value bigger than 0 will give you a smiling graph, and then the a value smaller than 0 will give you a sad graph. So that's what's going on. Now let's draw ourselves a parabola over here. And these parabolas are actually shifted horizontally as well. So you might find that the turning point, well, you have to find that the turning point this time is not the same as the y-intercept. Because remember, here is where the y-intercept is. The y-intercept is where the graph will cut the y-axis. And then the x-intercept is where the graph will cut the x-axis. Right? So those crosses, these two are the x-intercept, and that's the y-intercept. Right, so I hope you understand all of that. Now with this one, the first thing again that is the shape. So this we call the shape. Ne? So the shape could be a smiling or a sad one. Now, what else must you know? You must know that wherever the turning point is, its coordinates are derived from the p value and the q value. So here I will put P, and there I will put Q. So to get the coordinates of the turning point, you take the P value, it forms the X value. You take the Q value, it forms the Y value. Now you have the coordinate of the turning point. That is what's important in this standard form. So if you have the standard form, you know that you have the turning point. And remember, the equation of axis of symmetry, the equation of the axis of symmetry will be the x equals to the x value of the turning point, but in this case it's x equals to the p value because we obviously know the x value of the turning point is going to be p. So that's what we have over there. And it is symmetrical here. So if you cut the parabola here, then the left hand side will be equal to the right hand side. That's what we have to know there. All right. Now, you must also understand what the P and the Q actually tell you. They give you some information. We say when the P value is positive, the graph is shifted to the right. So currently you see that the turning point was supposed to be here, but now it's a little bit to the right. It's because the P value will be positive. If the P value is negative, then the graph shifts to the left. If the Q value is also positive, then the graph shifts up. If the Q value is negative, then your graph will shift down. So you can see here, it shifted to the right and it shifted down. That means that the Q value will be negative because shifting down, it means that the Q value is negative. Also here on this side, this Q value is responsible for shifting the graph up or down the same way as here. It goes up if the Q value is positive. It goes down if the Q value is negative. All right, so that's all you have to know with the second standard form over there. Then let's go to the last standard form. In that last standard form, we got the equation y is equals to ax squared plus bx plus c. I don't know what's causing this lag, but yeah, we got ax squared plus bx plus c. Now in this standard form, again, the a value is going to tell you your shape, how your graph is going to look like. If the a value is bigger than 0, meaning it's positive, it's going to be a smiling graph. If the a value is smaller than 0, meaning it's negative, then it's going to be a sad graph. But in the standard form, the c value is actually then the y-intercept. So if you want to know what's the y-intercept, it's actually the c value. The coordinates will be 0 and c. Whatever the c value is, that gives you the y-intercept. And then if you want to find the turning point, because remember, a parabola has a turning point. It's the point where the parabola will stop decreasing and start to increase, or stop increasing and start to decrease. Remember, that's the turning point. So if you want to find the turning point, you can first work out the x value of the turning point. So let's say the turning point will have the coordinate x of the turning point and y of the turning point, right? You can first work out the x value of the turning point here by using this equation. X value of the turning point is equals to minus b over 2a. So that's what's going on over here. Use this formula, then you might get something like, oh, x is minus 1. Then what do you do with this minus 1? You will substitute this x equals to minus 1 in your equation, which is then y. So you take this, you're going to substitute it into your equation, whatever equation you would have had. And then you substitute that, you're going to get the y value of the turning point as whatever it is. So that's how you deal with that standard form. It is very important you know how to work with each standard form in order to plot the graph, right? So let me just emphasize again here. Guys, the a value is the number in front of the x squared. So when we say a here, we are talking about the number that will be in front of the x squared. And then the b value is the number in front of the x. So this b value is the number in front of the x. And when I say c value, it's the number that does not have an x. So the c value that we're saying, it's the y-intercept, it's the number that does not have an x. So that's how you must see it. So let's practice some questions. I will leave it there with all of that. So let's practice some questions. And I I just want to add on here. So let's say range. I just want to add another question here. We're going to say, oh, well, let's not add anything. I think it's going to apply to one graph. All right. To say how it has been shifted. No, actually we should. Let's do that. Let's also mention how the graph. So explain the translation, which means slide, shifted. We have to talk about how it has been shifted. You can say how the graph was, it slided to this left and right and up or down. We'll also talk about that. So we got to answer all those questions. So the first question is to sketch the following. So we got to sketch this. Then we're going to give the domain and range. And then we're going to give the equation of axis of symmetry. We know the axis of symmetry is those dot lines. We have to give the equation. And over here, we did have an example whereby we said, where did we use one of them? Over here, we also say dot. Whatever the x value of the turning point is, that will give us the equation of the axis of symmetry over there. So that's very important stuff. But let's see, how do we plot using this standard form? Guys, you should see that this standard form is that y equals to ax squared plus q. You must be able to spot that this behaves like the first standard form that we have, okay? Now, the first step to plotting a parabola, you must first work out its shape. So the a value is going to tell us the shape. Can you see the number in front of the x squared, which is the a value, is -1? So that because the a value is -1, I know my graph is going to be a sad graph. So I know it's going to be a sad graph, right? I know it's going to be a sad graph like that. All right, so I know it's going to be sad. And then I'm also going to see, number 2, I want the TP, the turning point. Now, remember, we said the turning point is the same as the y-intercept. So this value, the q value, is going to give us the turning point. So the turning point in this case is 0 and 4, right? As you can see from the previous slide, we did mention, we said the turning point will be 0 and whatever the q value is. And that will be the same as the y-intercept. Because thirdly, what you have to work out in order to plot a parabola is the y-intercept. So you have to work out the y-intercept. But it's already given to us. It's that 0, 4 coordinate. And then fourthly, you just work out your x-intercept. And then you are done. You can then plot. So let's work out the x-intercept. When you work out the x-intercept, you must let y become 0. In this case, we can say f of x is 0 because y is now f of x. So I'm going to use that formula. Where there's a f of x, you must put 0 is equals to. So you copy down that formula. 0 is equals to minus x squared plus 4. We copy it down as it is, and then from here I'm going to take everything to the left hand side. So therefore I have x squared changes to positive, and then I get minus 4 equals to 0. So I translated them to this side, and then there's 0 there on the right. Then I factorize this. It's a difference of 2 squares. X plus 2, x minus 2 equals to 0. So then x plus 2 equals to 0, or x minus 2 equals to 0. So then x is equals to minus 2 and x is equals to positive 2. Remember from here, guys, it is now a quadratic equation, and you must know how to solve quadratic equations. If you don't, go to the algebra, you will learn how to solve quadratic equations and learn how to identify them. So now I have the coordinates minus 2 and 0, because remember the y value, we said the y value must be 0. And we have another x-intercept at 2 and 0. Now we are ready to plot. So we draw ourselves a Cartesian plane. You don't have to draw it up to scale. And then you will say, let's plot the turning point. The turning point will be somewhere here, where you have the coordinates 0 and 4. And then let's plot the x-intercepts. Well, the y-intercept first, which is also there. And then you plot the x-intercept, which is then somewhere here. I'll have -2 and 0. And then remember, same distance from there. I'll plot here. I have this coordinate 2 and 0. And then we said the shape needs to be a sag graph, so we make it a sag graph. Just make sure you curve it. It must be a curving graph, so put some curves in it. And then we write down this is the graph f of x. Like this, you get total marks, guys. You get total marks. Remember, this was the y-intercept, right? As well as the TP, which is the turning point. Now let's answer the questions that they have for us over there at the top. Firstly, they say give the domain and a range. Now domain is all the values of x that exist for this graph. So let's write down D for domain. How do you get the domain? Well, you're going to pretend as if you are walking on the x-axis. So you're walking to the right, ne? So coming from the left, you're walking to the right. And then you're going to scan up and down and ask yourself, if you're standing there, will you be able to see the graph? So if you were standing somewhere here, you'll see the graph there. If you were standing somewhere here, you'll see the graph somewhere down there, because remember, it continues all the way down. And if you were standing where this person, where I drew this person, it will be somewhere down there. And as you move to the left, the graph, you will still see it somewhere down there. So we ask yourself, what is the smallest value of x? So you will say x is an element of, right? So let me just give you the format. It will be x is an element of. You need to first write down the smallest value of x, and then you need to write then the biggest value of x, where you will still see the graph. So you ask yourself, what will be the smallest value of x? And you can see that you can go to the left as much as possible on the x-axis, but you will still see the graph. So you will continue all the way till -infinity. So the smallest value of x where you will still see the graph will be -infinity, and the biggest value of x where you'll still see the graph, remember, you walk this way and you'll still see the graph like this. If you are here, you'll still see the graph somewhere down there. If you are here, you'll still see the graph somewhere down there. So you will say, well, the biggest value of x will be infinity. That's how you get the domain. Now let's get the range. If you want to get the range, you get it more or less the same, except now you are walking on the y-axis. So you want to be on the y-axis. This time we're going to scan this way horizontally for the graph. You'll say, what's the smallest value of x where you will still see the graph? And you will notice that you can go down as much as you want. You will still be able to see the graph somewhere down there, right? So the smallest value of x, I'll say R for range. You say y is an element of -infinity. The smallest y value where you will still see the graph is -infinity. And as you go up, the biggest value of x will be here. Because when you're standing on this side, you're not going to see the graph anymore horizontally. There's not going to be graph there. The graph will still stop there at the turning point, and we know the y value there is 4. So the biggest value of x where you still see the graph will be then +4. And on +4, you do see the graph does exist on +4. So you put square brackets, because +4 is a number where the graph still does exist there, right? You can never stand on infinity, so we put round brackets. But you can stand on +4 and the graph can be there. It is there, so you put square brackets because 4 is included. So that's the domain and range over there. Now let's go to the equation of axis of symmetry. Now if you want to find the equation of axis of symmetry, this one, remember we said it's the x value equals to the x value of the turning point. So I'll write it here at the top. That is x equals to, what is the x value of the turning point? In this case, it is 0. So I'll put x equals to 0. that will be the equation of the axis of symmetry. This one is because we got it from that x value of the turning point. The equation of the axis of symmetry is x equal to 0. That means that I can come here. This is the line x equals to 0. It's a vertical line. If I cut it in half, this left side will be equal to the right side. They will be the same. They'll look exactly the same. They are mirror images of each other. So the equation of the axis of symmetry, we worked that out. Now let's explain the translation of the graph. If you want to explain the translation of a parabola, you simply focus on the turning point. So the translation, you focus on the turning point. Now, these coordinates were supposed to be 0, 0. They are not. The y value is 4. That means that the graph was shifted up 4 units. So if you explain the translation, you're going to write down and say, let's write down f shifted, okay, shifted 4 units up. That's it. You say f was shifted 4 units up. All right, so let's go over to the next question and let's try to do this question a bit faster, as now you have the basis of how we work with a parabola. So the first thing we have to do, we have to sketch this. And to sketch this, I first have to work out the shape. So remember, it has the standard form y equals to ax minus p raised to the power of 2 plus q. So the a value there is 1. So that means that okay, number 1, I need to find the shape. And we know that a value is equals to 1. So it's going to be a smiling graph. And number 2, I need to work out the turning point. Now the turning point in this situation will be whatever the p value is. If you see a minus 1, then that means the p value is positive 1. If you see a minus 1, it's positive 1. If there was a positive 1 there in the equation, then you write minus 1. So 1, and then the q value is this one. This is the q value minus 1 over there. So guys, I'm just emphasizing, if I had another function here that goes like p of x. P of x is bracket x plus 3 squared minus 1. Remember, the p-value will be the opposite sign that you see there. So if you wanted the turning point here, you say minus 3, and then you take the q value, which is minus 1. So the p-value that you see in the formula, the p there, the actual p-value will be the opposite sign. So just make sure you remember that. So the turning point is 1 and minus 1. And then thirdly, we need to work out the y-intercept. Now to work out the y-intercept, you must make x 0. So we're going to write down g of 0. Where there's a x, you put 0 is equals to bracket 0 minus 1 squared minus 1. So g of 0, this is going to be positive 1 minus 1. So I'm going to have my y-intercept at, well, this is 1 minus 1, where g of 0 is equals to 0. So the y-intercept's coordinate is at 0 and 0. That's the first thing that we notice. Now let's work out, fourthly, the x-intercept. Now to work out the x-intercept, all we have to work with over here will be x-intercept. Now we make g of x equals to 0. So where there's a g of x there, you're going to put 0 is equals to bracket x minus 1 raised to the power of 2 minus 1. Now we have to solve this, and it's a simple quadratic equation where we can just factorize the difference of two squares, x minus 1 plus 1 minus 1. So then we end up having this bracket as x and the other bracket as x minus 2. Then now we can say x is equals to 0 or x minus 2 is equals to 0. So then we have x is equals to 2. So the coordinate is 2 and 0. and the other one is 0 and 0. So we have all the points that we need in order for us to plot. So we're going to focus on all those points as well as the shape, and we're going to plot our graph. So now we go to the Cartesian plane and we are going to sketch. I'll sketch it a bit smaller here. Then let's plot. We know it needs to smile. So let's first plot the turning point at 1 minus 1. So positive 1 is here and minus 1 will be somewhere here. So I'll make a point here. And I know it has to go up because it needs to be a smiling graph. It's this point that we see over there as a TP, right? And then we plot 0 and 0 will be somewhere here. 0 and 0. So that's the y-intercept. And we plotted this, and then we plot the x-intercept, which is also here, and then this x-intercept, which will be at 2, so somewhere here. Now we have to put, this is the coordinate 0 and 2, and this is the coordinate 0 and 0, and we have all the coordinates, and then we can just make a graph like that. Like that. And we are done. This is the graph g of x. Now we answer, what is the domain and range here? So the domain will be x is the element of. Remember, I'll be pretending as if I'm walking on the Cartesian plane and I'll scan up or down. So what's the smallest value of x where I can still see the graph? I can still see the graph here somewhere. And when I'm standing here, I can still see the graph somewhere up there. And wherever I'm standing on this x-axis, I'll still see the graph. So the smallest value of x where I would still see the graph is minus infinity. The biggest value of x, remember we can continue going. I can see the graph somewhere there. When I was here, I can see the graph somewhere up there. So it's minus infinity to positive infinity. And that will be the case for most parabolas that you will encounter this year. The domain will mostly be negative infinity to positive infinity. Now let's get the range. The range, we say y is an element of. The smallest y value where I can still see the graph. When I'm standing somewhere here, I can't see the graph anymore. I forgot to give the coordinate here. The coordinate is 1 and minus 1. Okay, you must indicate that. I wanted to indicate the minus 1 here because I indicated a 1 there. You can either do it this way or you can indicate the coordinate. Right, so the smallest value, the smallest y value where the graph is still there, where I can still see it, will be here at minus 1. Because at minus 1, I see the graph here with its turning point. So I will say the smallest value of x where I can still see the graph is inclusive minus 1, which is the y value of the turning point. Just take note of that, all the way to the positive value of the turning point. So that I can go as up as I can and I can still see the graph. So that's the domain and range. The equation, so equation of the axis of symmetry, right, will become x equals to, the x value of the turning point over here is positive 1. So x equals to 1 is the equation of the axis of symmetry. And how was the graph translated? The translation, you look at the turning point again, guys. The x value is 1. So then the graph was, you say, shifted 1 unit right. So 1 unit right. Okay. And then you also say shifted 1 unit down. 1 unit down. You should be able to see this from the equation, from the standard form there, from the equation or the formula they gave you, from this. This is the Q value, and we said if the Q value is negative, the graph shifts down. This is the P value, and remember I said the P value will be the opposite sign of this. So the P value in this case is positive 1. And if you go all the way back to the characteristics, I told you if the P value is positive, the graph shifts to the right. So just make sure you understand that as well. So that's everything that we have to do with that. With this one, we have described everything. Now let's do the last question that we encounter here. So sketching is something you should be able to do for all three standard forms, and you must know what each standard form gives you. So let's do this last one here, whereby they say this is the standard form y is equals to ax squared plus bx plus c, right? That's what's going on here. So the first thing, we have to look at the shape always. So we look at the a value, it's -1, so our graph is going to be sad. Then secondly, we need to work out the coordinates of the turning point. So I want the x of the turning point and the y value of the turning point. So I need to use the formula x of the turning point is equals to minus b over 2a. Because guys, I did just mention now that if you want to find the turning point and you have that standard form, you can use that formula over here. I hope you guys can see it over there. Make sure you know your characteristics, because that's how you're going to be able to plot. In this situation, I'm going to substitute minus, and the b value is obviously the number in front of the x. So I put 3 there, and then I say 2. The a value, we already said it is -1. So I need to put -1 in there, and then I simplify that out, and I'm going to get -3 over -2. So then I get 3 over 2, and we're going to write this now. So continuing, I take this value, I'm going to substitute it in there. So I put h of 3 over 2. Where there's an x, you must put what this is, because that's the x value. Minus 3 over 2 raised to the power of 2 plus 3 over 2 close bracket minus 2. So we put this in our calculator, and let's see what we are going to get. So let me see if I can share my calculator with you guys. Yes, I can. So we put minus, and then say 3 over 2, then we say bracket raised to the power of 2. Then we have to go down and say plus 3 brackets, and then we want to go 3 over 2. We're just substituting into the calculator right now. Then you say minus 2, and it gives us 1 over 4. So we put 1 over 4 in our calculate in this. So then the equation of the turning point in this situation, it must be 3 over 2. That will be 1,5, while 0,4 is 0,25. So I'll say 0,3, because remember, in your calculator, you can just change this to 0,25. So let's run it off to 0,3. And we know 3 divided by 2 is also going to give us 1,5. So we are done there from the calculator. And then now, thirdly, we have to work out the y-intercept. Now, the y-intercept, you don't work it out, because I already told you that the c value is your y-intercept. So we say 0 and -2. That's the y-intercept. So you must get that. Number 4, we get the x-intercept. Now the x-intercept, we must make h of x become a 0. So you put 0 where it is supposed to be a h of x. Then you say 0 is equals to minus x squared plus 3x minus 2. Then we're going to divide every term by -1 to change the sign of this, because you want the term with the x squared. Because guys, this is now a quadratic equation. If you don't know how to solve quadratic equation, please refer to the algebra. Okay, so we're changing the signs of all of this. Is going to become positive x squared minus 3x positive 2. Now we need to find the factors, and factorizing this trinomial is going to give us x minus 2 and x minus 1. And then we're going to get x is equals to positive 2 or x is equals to 1. So my coordinates are 2, 0, and my other coordinate is 1 and 0. So now, using all that information, we should be able to plot this perfectly. So you use the fact that your shape is like that, your turning point, y-intercept, and your x-intercepts. So let's plot a nice small parabola here. Let's plot firstly the turning point. It's at 1.5. So somewhere here I'll have 1 and I have 1.5 here. And I need to go to 0. Positive 0.3 will be here. So slightly there, I'll have a turning point here. And then remember, it must go down because it's that point over here at the top. By the way, guys, okay, I will tell you now. So let's just say this is the coordinate 1.5 and 0.3. That's what you will have over there. Then let's plot the x-intercept will be at positive 1 and the other one will be at 2. So I have 2 and 1. So I indicated that. And then the y-intercept is obviously going to be at -2. So let's plot this. Make sure you put some curves in it. Then somewhere here at -2, we're going to have this, and this we call h of x. All right, h of x. All right, so now you are able to plot such a function. Remember to go through all these steps whenever you're giving the particular standard form. You go over through all these steps and then you'll be okay. There's not a parabola that you're not supposed to be able to plot. You should be able to plot all of them if you know all these 3 types of standard forms, their characteristics, and the examples on how to plot. All right, then from here, let's work out the domain and range. So to work out the domain, we're going to say x is an element of -infinity to positive infinity, because the smallest value where you can still set a graph is -infinity, and the biggest value where of x where you will still see the graph is positive infinity. Let's go to the range. The range will be y is an element of from -infinity all the way till positive 0.3 and include it. So you include this one, because that's if you're standing here on the y-axis, the smallest value where you can still see the graph, you will see it forever going down. The graph will be somewhere there. So when you're going down on the y-axis, you will see the graph all the way till -infinity, and when you're going up, you will see it only up till the turning point, which then yields this answer. Then the equation of symmetry is x equals to 1.5 because it must be equal to the x value of the turning point. And the last thing is the translation. Guys, the graph has been translated up 0.5, so shifted 0.3 up, and then it's also been shifted. So you look at the turning point, right? Shifted 1.5 right. 1.5 right. All right, guys. So that's it for this video. I hope you can rewatch this as many times as you need to be able to plot this. It is as simple as this, and I will see you in the next video.